I can't tell you how happy I am to see so many .NET fans at a Java conference. It's, that's right. We're starting the movement. We're starting the .NET Renaissance, as they say. Hopefully it starts here at Spring One platform. So welcome everyone. This is the first of, I believe, 3 back-to-back .NET sessions this morning. So I guess we can get started. My name's William Martin. I'm Pivotal R&D product lead for .NET and Windows support. And I see a lot of familiar faces in the audience, which is really great. And I'm here to talk to you today about the latest capabilities for supporting .NET and Windows applications on Pivotal Cloud Foundry, and give you some insight into our product strategy and why we believe it's a great strategy to move forward, and then how you all can get involved. So a number of pivots are posting this safe harbor statement, so I'm doing so for compliance with our legal team. It essentially says that anything that you hear that can be construed as a roadmap is not actually a commitment to delivering those things. So if you are making a decision about whether to adopt the product offerings that we have, please make that decision based on what has actually shipped, as opposed to what we claim we're going to ship, at least in terms of line item features. In addition to that, I wanted to make a short disclaimer about our collaboration with Microsoft. We do have a collaboration with Microsoft. We have a number of collaborators on their side. I wanted to make sure that it was understood that I'm not speaking on behalf of any of our Microsoft collaborators, but I hope that they're proud of the work that we have done and that we're painting them in a good light, because that's my intent. So, who are we? I'm William Martin, I'm product lead, but I'm really here as a representative of many, many pivots who are working to make .NET and Windows successful on the platform. So here are most of the people who are working actively on this, a few in the audience here. So if you get a chance to speak with any of them while you're here at Spring One platform, that would be awesome. But this is actually for everyone back in the New York office who is working right now on this support to make sure that all of you were made aware of their presence and their contribution. So, and I'll kick off by kind of laying out what I'm calling kind of the .NET diagnosis, and hopefully this resonates with you. This is based on a lot of feedback that we've gotten from customers over the last 3 years about their experience, not just with PCF, but with their challenges modernizing .NET in general. And I think that the way to summarize this is that kind of .NET enterprise portfolios are just inherently complex. There's a lot of factors that affect .NET applications that don't necessarily affect Java applications. Java is a kind of a different beast in a lot of ways, similar in a lot of ways to .NET Framework, but the cloud native movement, at least as espoused here at Spring One platform, is oriented around Java. And I think .NET is really poised for great change over the next few years. And really, some of that challenge comes down to this kind of this set of challenges and opportunities. One is like workloads in your data center may not be as portable as you would like them to be. Like even moving them from one server to another can be a challenge, or moving them, especially when you're faced with the question of do you go from an on-premises deployment to a public cloud. Like that can be an inherently difficult question to start to grapple with. Workloads by themselves might be difficult to modernize. Like a number of conversations I've had at Spring One platform already are about a .NET monolith that is still adding business value as it is, but itself might be difficult to follow through with some of the modern advice that you're getting from the cloud native movement. So like strangling the monolith and breaking it up into microservices. That like, how do you make a strategy decision around that? How do you justify that business decision if you're an app dev lead or the lead of a business unit? Like, how do you start to justify that investment? And maybe even technically, it's just very difficult. There's a high cost to maintain a lot of these workloads, especially when you start considering all the Windows instances that you have running. If you're running .NET Framework on Windows Server in particular, you might have different versions of Windows Server lying around. A lot of customers that I've worked with have many different versions deployed over time, and they'll have one sticky server that's like Windows 2003 that they don't want to touch because it had, like, no one knows how to configure that server or reconfigure it, and no one really at the company knows yet, like, how to deal with the code and the app that's sitting on that server. So what do you do? And then it's difficult to adopt new Windows versions. Maybe there are deprecations and APIs that are happening with the new version of Windows that comes out. Microsoft has started shipping a new version of Windows every 6 months now, instead of in addition to the 2-year cadence for their long-term releases. So how do you strategize around that? Is it even worth it to adopt a new Windows version right when it comes out, or does it take you 2 years to adopt that version? And then the universe is pointing towards .NET Core as the future, and there's a bright future in .NET Core. It's actually added new life to the .NET ecosystem. It's bringing in people that wouldn't normally have considered .NET or even C#, and they're taking a serious look at .NET Core now as something that's cross-platform. It's readily accessible. They can run it on their Mac. They can engage what is now a more open community now that there's a .NET Foundation and an open community around it. But it's still costly to rewrite your apps. Like, a lot of our customers, a lot of the feedback that we get is like, yeah, that the story about .NET Core is really great. However, I still have to make a business case for saying it's worth 2 years of investment for half a dozen engineers to rewrite this monolith into .NET Core. And then finally, I think one of the questions that comes up all the time is like, .NET Core might not meet all of your needs at this moment. There might be libraries or frameworks in .NET Core or in .NET Framework that don't have an equivalent yet in .NET Core, and that's kind of limiting how fast you can adopt the .NET Core world. But at the same time, there are a bunch of opportunities, especially the opportunities that Microsoft is setting forward. So .NET Core in particular, their emphasis on Azure Cloud and the services that it offers, not only to .NET, but in the kind of polyglot universe that they've been embracing the last few years and creating the last few years. Hybrid and multi-cloud questions start to come up. What do you do about Docker now that there are Windows containers? Now you can look at Docker and the messaging from Microsoft around Docker as a potentially viable option to manage some of your workloads. And then there's this question about all the open source patterns and projects that are gaining attention. So patterns like microservices, event sourcing, service meshes like Istio, container orchestration, particularly with Kubernetes, function services, and so forth. But there's this chasm that we're finding between the reality that enterprises are facing and that bright future that we all want to get to eventually with .NET Framework. And so a lot of the work that our teams at Pivotal are working on is providing the way to cross that chasm, so to speak, to find the right platform, the right practices, to move and modernize the right workloads at the right times, and finding that balance between what do you have to transform and rewrite versus what can you just move over to a new platform, particularly Pivotal Cloud Foundry. And so that's pretty much what our mission at Pivotal is. Most of the .NET and Windows teams are based in New York. We have a small outshoot in Toronto, and then our field teams are spread around the world. And all of those contributions and all of those learnings are coming back to the product in one way or another. So the vision that we're starting to sell now and we're starting to kind of rally around is this notion of a complete transformation platform. How can we enable a kind of seamless transition from the reality that you're facing now to that .NET Core microservices future, or however you frame the future. If it's, I've had a number of conversations already this week about event sourcing and event-driven models and function services that could be available for .NET Framework and .NET Core applications. So as you start to formulate and look at these patterns, where is the platform that can help facilitate that and reduce the friction to get to that platform? But at the same time, there's an opportunity for developing new practices at the same time. So it's not necessarily a world or a future where you can say all of the things that I've been able to do with .NET Framework, I'll still be able to do in a cloud-native world. We're still adopting this, or trying to strive towards this place where .NET Framework apps can adopt the 12 factors, and you can produce 12-factor .NET applications. And the way that we've been framing this now, and this comes from one of our platform architects, Cornelius Mendoza, is to move and improve those apps. So as opposed to taking a lift and shift approach, you take an approach to say, I want to move these workloads over to a new platform and at the same time improve them in some material way. And a lot of the practices that we're doing at Pivotal aren't just solely focused around the platform and the product, but also advising how to use that platform and how to transform these applications at the same time, and how to transform the way your businesses work, et cetera, and so on. And in particular, what I want to emphasize throughout this presentation is this approach to co-create these practices with you, with the .NET community, with our customers. And I think we have a lot of examples of where that's been successful so far. So Pivotal in general always espouses that these two things come together, platform and practice. So to achieve this ourselves, we have a set of guiding principles that kind of form the way that we approach product development. So the first and probably the most pervasive phrase that we use internally is this notion of pragmatic parity. So Pivotal Cloud Foundry is powered by Linux, and particularly the workers that run containerized Linux workloads. And Windows is just a different beast. It has a different way of thinking about containers. There's different APIs. So what is the way that we can achieve a kind of parity in the platform so that when you hear a value proposition about the whole platform, that applies equally to .NET, so as it does to Java. So that's the parity part, but done in a pragmatic way. So we acknowledge that Windows is going to behave differently. So we might not be able to implement a capability in just the same way, but we'll achieve something similar. But we do want to stay true to those core value propositions, and we also want to enhance the platform to support .NET and Windows in a more effective way. We're always looking at Microsoft to seeing what their cues are. And so if you were at Microsoft Build earlier this year, the emphasis is no longer on like .NET and Windows developers. You're either a Microsoft 365 developer or a Microsoft Azure developer. And that ecosystem, that integration that happens between those two universes is the kind of the core developer experience that Microsoft is known for and is trying to enhance. And we want Pivotal Cloud Foundry to be part of that as well. For enterprises, security is always top of mind, so we take a secure by default approach on all of our work, not just the configuration of the operating system, but also the implementation of the runtime and any other integration we have. And then finally, co-create these features and capabilities with our customers and with our partners. And I'll tell you a little bit more about what that means later. But the way that we start to frame what our product and practice strategy is trying to achieve is generally around how you look to investing in your portfolio of applications. So what have you decided to build anew? What have you decided to modernize? And what have you decided to lift and shift to a platform that might give you value out of the box, but you're not necessarily interested in rebuilding that application. And so we have a number of evolving product offerings that handle different slices of your portfolio. So in particular, I'm going to be talking about the shaded box here, Pivotal Application Service for Windows, and then talk a little bit about some of our aspirational future with regards to containerized workloads. But as far as the corollary practices go, it looks something like this. Like, what are you building new? You know, maybe you target .NET Core for that, and then shift to .NET Framework when you run into a blocker where there's a library that you don't have just yet. And so the boxes on the right start to portray the Windows and Linux side of Pivotal's two primary offerings right now, Pivotal Application Service and Pivotal Container Service. And so maybe part of your investment strategy is to take that monolith and actually spend the effort to break it down into and deploy it as microservices. Maybe it's something that you just migrate with a few changes. And then finally, what is that maintain strategy? Like, what do you actually do containerize and find a way to kind of care for that app, but not changing it very much? And where are there cases where it's better to put it onto do a lift and shift onto an application platform and get the benefits of that, but without worrying about the container construction. And so I'll kind of leave this for probably for the slideshow when it's posted later, but the value that we're trying to offer both applications and operations really center around productivity and the benefits of automation. So, and also being able to deploy all the things side by side. So .NET Core, .NET Framework, Windows hosted applications, can everything live next to each other? Can we enable all of those strategies in the previous slide, like breaking up the monolith, but also adopting standards like OCI, enabling, and then finally delivering all of the value that Cloud Foundry is known for, like patching .NET apps and the container image live with no downtime, transparently patching Windows, the Windows VMs without having to worry about Windows updates failing on a certain percentage of your servers. Like, you're guaranteed for that to work every time, and so on. So, and then the evolution of this happened in a kind of organic way. If we think about the capabilities of the platform that are available to both .NET and Java, I tend to use this Venn diagram. I mean, what can't you portray with a Venn diagram to describe these common features? So if you imagine, like, we're getting, like Pivotal has gotten, obviously, why we're here, a lot of traction in the Java world creating the Spring ecosystem. The first bit of feedback that we started to get around 3 or 4 years ago was our customers also have .NET workloads. What do you want? Like, what can you do for us with that? And at the time, we couldn't support them. It was kind of a PlayStation versus Xbox scenario where Xboxes run Windows, and so they weren't really able to play along with the Cloud Foundry ecosystem at the time. But that was an opportunity, and in late 2015, we shipped a product called Diego for Windows, which is kind of a manually deployed Windows VM, but that has all the Cloud Foundry runtime installed on it with an MSI installer. We kind of affectionately call it the MSI, trying to stick with that, trying to stick with Windows and Microsoft technology. So this, this in particular was able to, I lost my window here. All right, here we go. So in particular, this was before the era of containerization on Windows. So this used a containerizer called Ironframe and delivered with Windows 2012 R2. And so the feedback that we got was super positive. Developers loved the CF push experience, but operators hated it. You still had to manually deploy the VM, and you still had to procure that VM. So last year, we introduced Runtime for Windows, which automated the deployment of Windows VMs with BOSH. And so now this was the first-class operator experience that our customers had been asking for. So it still used Windows 2012 R2, still used the Ironframe containerizer, which had a number of limitations to it that we've now overcome since Windows Server containers were introduced in Windows Server 2016. And so earlier this year, we shipped a product called Pivotal Application Service for Windows in March. that delivers a runtime that uses true Windows containers and finally lets us achieve the potential to offer that pragmatic parity of features to Java and .NET at the same time on the same platform. And all this time, at the same time, we've been investing in what those .NET and Windows enhancements look like. So particularly the Steel Toe project, which you should stay in this room and hear more about after this presentation. So, so that's, in essence, what we consider a complete functional platform with first-class support for both Java and .NET. And so diving quickly into PASW for Windows, this is, for those of you who are new to Cloud Foundry, this is an extension to Pivotal Application Service that deploys Windows Diego cells alongside Linux Diego cells. And so if you've seen this diagram before in other presentations, the .NET and Windows stack lives kind of in this, with these component bubbles. And the first place where the rubber hits the road here in terms of the kind of paradigm shift that this implies is BOSH, being able to manage and deploy Windows VMs essentially with a few clicks, as opposed to what you might be doing now, setting up Windows VMs manually, running IIS, managing them with Active Directory. In the BOSH world, BOSH achieves a lot of the same goals that Active Directory does, but with a different paradigm, something that's more declarative, something that uses an immutable operating system configuration, as opposed to managing VMs in a dynamic way. So in PCF Operations Manager, this is what it looks like. It's just a tile that installs side by side with either the small footprint tile or with the full PAS tile. There's a deploying many Windows servers is just a drop-down menu. So if your Cloud Foundry is configured with the right resource space on your IaaS, then all you have to do is pick how many Windows servers you want, and that scales out automatically. So for those of you who have used the 2012 R2 product before, there are a number of notable improvements, and we encourage you strongly to consider migrating away from the 2012 R2 product over the next year and adopting PASW for Windows. Now, you get all the advantages of what Linux containers offer the other side of the platform, so an improved runtime performance, there's greater app portability, you can remote debug into a Windows container now. You can SSH and get a PowerShell prompt inside a Windows container and poke around, and you have that isolated experience, and you're able to leverage better integrations with IIS and Windows. We have all of the capabilities of the platform now that automate the provisioning of dependencies and the providing of dependencies to applications. It's a really, we're really excited about this product. It's going to be the kind of last major paradigm shift for the Windows stack. So this is going to be the future moving forward. And so as far as some of the .NET practices that then go alongside PASW for Windows, this is a chart that our design team and field team has made that describes how .NET applications then must be transformed in order to run currently on the platform. And part of our goal is of developing the platform and practices in tandem is to understand the impact of this kind of the flowchart and see where are there opportunities to improve this experience where the platform has to change, or where are there opportunities for a practice to evolve, to move us closer to that modern world. So some of these diagrams I'll skip through pretty quickly, but the CF push experience is, for those of you that are familiar with Cloud Foundry, is a matter of once the tile is deployed, specifying the Windows 2016 stack and the HWC build pack, and the same infrastructure that deploys the apps to Linux will wrap up your .NET application and deploy it to a Windows cell and automatically throw that into a Windows container for you. And so some of the feature details I'll leave for you all for later. The middle column here are the places where we start to see some of those kind of pragmatic parity improvements. So things like CPU metrics are behaving the way that they should behave, because we're getting true metrics out of the container from the Windows infrastructure, as opposed to getting the shared metrics that would have existed on 2012 R2. The SSH experience is huge, to be able to get a PowerShell prompt directly in a container. And finally, on Monday, we shipped the third version of Pivotal Application Service for Windows, which gives us multi-build pack support. So if you're new to Cloud Foundry, a build pack is essentially a packaging of dependencies that a particular app needs to run on the platform. So we have build packs that package Java, Ruby, Python, and for Windows, it's the Hosted Web Core build pack, or HWC build pack, that provides you access to the same web hosting facilities as IIS typically provides. So a couple notes about how it works. The versions of Windows Server that are out there are starting to increase rapidly. Every 6 months there's a new one that comes out. So this is the core set that that introduced Windows Server containers. There's a long-term servicing channel which ships every 2 years with 5 years of mainstream support and 5 years of extended support. And then the versions that have the year monikers, so 1709 and 1803, for example, are the semi-annual channel releases that ship new container features and new operating system features at a much faster cadence. Those are the ones that PASW for Windows uses, so that we can leverage those container features, but also provide feedback to Microsoft on what we discover with every new release. And we're all looking forward to Windows Server 2019, which will hopefully stabilize a number of the container APIs that we leverage for the platform, so which is expected next month. This is a little note about the support cycle that exists for us. In case you're worried about the support for Windows versus the support for the appropriate PASW for Windows version, we try to align our versions quite clearly with the support cycle for the semi-annual channel releases. So hopefully this chart can be a reference for you if you have that question in mind. But I think that the cool part and the core of the technology stack here, and what's really providing this value in PASW for Windows, is really the containerization. This is the new piece of Windows that I think has formed a lot of questions in our customers' minds about what do I do about Windows containers? Like, do I use Docker? Like, are there other platforms available? What value can I get out of these platforms? And PASW for Windows is one of the few enterprise production-ready products on the PASW products on the market that uses Windows Server containers. So we don't use Docker, by the way. We drop down and we don't ship IIS either. We kind of drop down a layer in the stack and use Hosted Web Core and the same APIs that Docker consumes when you create a Windows container with Docker. And it's really about these three runtime plugins on the Windows cell. What we call a Diego cell is the kind of worker of Cloud Foundry. That is what creates and manages the lifecycle of a single container. And this kind of describes, or is intended to describe, what happens to your code when you push your app. So you build your app in Visual Studio, you pop over to PowerShell and run CF push, CF being the CLI for Cloud Foundry. And that goes through a process we call staging, which effectively takes the build pack, the HWC build pack, and provides it with a runtime server that then gets tarballed up into what we call a droplet, an immutable version of your application that has all of the dependencies that it needs to run. And then that's auctioned off to the available Windows VMs. And the Windows VMs that can accept that workload kind of raise their hand and say, I'll take it, and then build a container that diagrammatically looks something like this. So the droplet itself is this combination of your application code and the build pack. that is designed to fit into an environment inside the container we call the root file system, or rootfs. And the base of that file system is a container image that comes directly from Microsoft. So this comes from, when you're installing and deploying the tile, those bits come from Microsoft and are deployed at deploy time. So in this sense, what this does is make a consistent OCI-compliant container image that your application runs in. And because of that contract between the build pack and the droplet and the root file system, which are all known and immutable, we can guarantee that that application instance will run every time, will run successfully. If it runs successfully once, it'll run successfully at scale when you scale the application out across VMs. So this is a note about the offerings that Microsoft has in terms of their container image. We ship with the Windows Server Core container image, which is about 1.5 GB in size, which can support .NET Framework. You might have heard about NanoServer being a possible container image. That's a very stripped down version of Windows that's less than 100 megabytes in size, but it's not designed to carry full .NET Framework. It's designed out of the box to host Windows executables and perhaps even self-contained .NET Core applications. There are two forms of isolation. We ship with the shared kernel isolation model. There's a way to kind of wrap a Windows Server container in a VM and dedicate a kernel to it. That has a lot of overhead, about 3 gigabytes in RAM for every container. And they take about a minute to start up, at least in our testing. So we're still looking for demand for that particular type of isolation. But for now, this combination of Windows Server Core with a standard shared kernel model offers an analogous form of isolation to Linux. So we're happy shipping it in its current form. But in general, I wanted to leave you with this notion, like how is the platform able to adapt to your workload's needs? First, there are the cloud-native best practices that we're working on, hopefully with you, at the very top of this architecture diagram. So being able to change the application so that it runs in a cloud-native way. There are new features in PAS for Windows, particularly build packs, that enable you to package dependencies and offer them to developers. So when you CF push, you can specify a particular framework that you want to support yourself, or we're working with a number of our ISV partners to offer vendor-provided dependencies like APM agents, for example, so that you can CF push and just drop in the APM agent without having to configure it yourself. If you need to modify the Windows VM itself, the BOSH add-ons are an option. And then finally, if there are changes that are needed to the platform itself, we encourage you heavily to reach out to us and work with us on those needs. We often take feedback about security posture and other related features and incorporate that into our operating system definition that we ship. And so everyone benefits. You don't have to manage that customization anymore, and everyone gets a better security experience, and we're able to maintain a better security posture. So then there are definitely other opportunities in the feature area of PAS for Windows that can benefit from your feedback there. So that's pretty much it for the capabilities of PAS for Windows that have evolved over the last 3 years. So hopefully this encourages you to at least give it a shot, like deploy PAS for Windows and see what the deployment experience is. And as always, I and our product team are open to feedback. You can reach us on either through your Pivotal account team or in the Cloud Foundry open source Slack account. So thank you very much.